Okay, we have some brief notes on graphing quadratic functions in intercept form. This is from chapter 5.2. Intercept form is y equals a, being the leading coefficient, times x minus p times x minus q. Okay, so we have the problem y equals 1/2 x plus 4 times x minus 2. Now you need to pay, when you're figuring out what p and q are, you need to pay particular attention to the pattern. So we know a is 1/2. So let's just put that down. We know it opens up. We have x minus p, but we have x plus 4. It doesn't follow the pattern of subtraction, so instead of being 4, it's going to be -4. Then we have x minus q, and then we have x minus 2. So q is, in fact, the integer 2. You just write the integer. When it doesn't follow the pattern, like it doesn't in x plus 4, then it's the opposite of that. Okay, our first step is the axis of symmetry. I'm going to come back to that. And then we're going to have the vertex. We'll come back to that as well. And then we're going to start right away with finding the x-intercepts. Okay, the x-intercepts are going to be p and q. So we know that they're going to be p and q, which is -4, 0, and 2, 0. But I want to show you another way in which, if you forget what they're supposed to be, you can actually find it using the intercepts. So what we're saying is, what value would x be when you add 4 to it that would give you 0? Because for an intercept, you can see that both of the y values are 0. So what you're trying to do is make this y 0. Well, if either of these, x plus 4 or x minus 2, if either of those factors are 0, then the entire thing would become 0 because of the zero product property. So y, I'm going to write it down, y equals 1/2 times x plus 4 times x minus 2. So for the zero product property, we would say, what would the value of x be to give us 0? Well, we know it's -4, but here's how you do it when the problem's a little more complicated. You subtract 4 from both sides, and in fact you get x equals -4, which the x-intercept is -4, 0. So if this were 0, if this were -4, -4 plus 4 is 0. 0 times whatever this is 0, times whatever that is still 0, so your y value would be 0. This is the zero product. 0 means just 0. Product means in multiplication property. So all that means is when you multiply by 0, you get 0. So that's all we're using is the zero product property. Okay, we know that the value for x minus 2 to get 0 would be 2. But if you aren't certain, you would just, if it's a little bit more involved problem, you would go x minus 2 equals 0. To get the value of x, to make it equal 0, you add 2 to both sides. And x equals 2, just as we predicted. Now the ordered pair for this is -2, 0. Excuse me, didn't mean to write that negative. Back here. The ordered pair for this is 2, 0. And you can see that's what we plotted here. So the zero product property is sometimes, you're using it, but it's sometimes not necessary, meaning you can do it mentally. Now, you've got 2 points. You're going to need three more points. So let's start with just getting that axis of symmetry drawn. There is a formula for it, but before we do that, let's find the middle of these 2 points. Because remember, the axis of symmetry splits a parabola into 2 equal parts. So if we go 1, 2, 3, 4, 5, 6. You can see that there's going to be 6 in between. So we have 1, 2, 3, and 1, 2, 3. So the axis of symmetry, and it's not always this easy, is going to be x equals -1. Now let's show you in the formula how that works. So on the axis of symmetry, you take this x-intercept, okay, the p value, -4, and combine it with the other x-intercept, the 2, the q value. And whenever you want to find the middle of something, you divide it by 2. This is just a midpoint formula. So we have -4 and 2, which is, oh, I should have put my x equals out in front here. Let me fix that. So negative 4 plus 2 is negative 2. X equals negative 2 divided by 2. And fix this up just a little bit. And negative 2 divided by negative 2 would be x equals negative 1, which you can see right there, x equals negative 1. Now we go to the vertex, and the vertex is going to have the same x coordinates, so it'll be negative 1. Same x coordinate as the axis of symmetry. What we're trying to find is y. And so we would have y equaling, you just go over here, a is a half times, our x value is negative 1, so negative 1, put it right in there, substitute it, plus 4 times, substituting that x, negative 1 minus 2. Okay, we're going to want to use the additive inverse, so y equals 1/2 times negative 1 and 4 is 3. And then I'm going to use the additive inverse here, negative 1 plus a negative 2. And so we have y equals 1/2. We've got times 3. And then we've got negative 1 times negative 1 plus negative 2, which is negative 3. And so we're ending up with 3 times negative 3, which is negative 9. And if we took half of that, yes, we would get negative 4.5, but I'm just going to write it as y equals negative 9/2. So it's a fractional amount. So we go out to, let's put it right here, negative 9/2. We're going to go out to negative 1, then we're going to go down to negative 4.5, which is negative 9/2. So negative 1, negative 9/2. We know this parabola opens up because the leading coefficient is positive. And we need 2 more points now. We're going to be able to use 0, but that doesn't always help us. But we know that 0 is to the right here, so we could use it. If you choose to use something else, it's fine as well. So the last step, this was our 1 step. The axis of symmetry, 2 is the vertex, but you actually did 3 first. Went back up and did 1 and 2. And then 4 is to find 2 is to find another point and reflect it. I'm going to go ahead and use 0, just because 0 is usually easy. It's not as easy in this one, but it's still fairly easy. So we're going to have x is going to be 0. And our y we'll find out, and our work goes into this equation. So y equals 1/2 times 0 plus 4 times 0 minus 2. Again, it's still going to be pretty simple. So y equals 1/2. 0 plus 4 is 4. 0 minus 2 is negative 2. 4 times negative 2 is going to be negative 8. If you take half of that, it's negative 4. So y equals negative 4. So 0, negative 4 is our ordered pair. 0, negative 4. Now, we're going to reflect that. So this is 1 from the axis of symmetry. We're going 1 to the other side. It's going to be negative 2, negative 4. And then we're simply going to connect our points on our parabola. And there you go. That is the graphing of a quadratic function that is in an intercept form. One thing I did want to point out, you may have already seen it, but see how we found P and Q, negative 4 and 2? We would have known right away, even without calculating the zero product property, we could have known right away what our intercepts were. I'd just like you to know how to calculate the zero product property, because when we get into solving, solving factored problems, we're going to have to use that zero product property. So it's a good thing to know how to do step 3. Okay, I'd like you to try this one on your own. Then go ahead and shut the video down. And so try it. The video shut down. Then turn it back on and see how you did. Let's see if you can remember from the classwork and from the previous example how to do this. If you get stuck, maybe go back and look at the previous problem by scrolling back. Try to do this one first before you turn on the video without just keep continually turning on the video to hear how to do it. Also, pay really close attention to the x minus p times x minus q pattern. That is important. Okay, some of this problem was a little more challenging than the others, but not initially. So you have a p, it follows the pattern minus 1, so your p is 1. You have a q that does not follow the pattern. It says minus q but plus 5, so it's a negative 5. Those are going to be your x-intercepts, so 1, 0, and negative 5, 0. Now, you can actually find the x-intercepts using the zero product property. So we already know what it'll be. What will the value of x be when you subtract 1 to get to 0? Oh, that's going to be 1. So there you go. X minus 1 equals 0. Add 1 to both sides. X equals 1. X-intercept is 1, 0. Okay, for the x plus 5, negative 5 would make that 0. That would allow us to use the zero product property. If it's a little more complicated, you just go x plus 5 equals 0. Subtract 5 from both sides. X equals negative 5 and negative 5, 0. All right, now, I went ahead and calculated the axis of symmetry, which is basically a midpoint formula. P plus Q divided by 2. So that's the x values. Negative 5 plus 1, which is negative 4 divided by 2, is going to be negative 2. But you can also see I drew in, and I'll do it in a different color now. There's 1, 2, 3. There's the axis of symmetry, 1, 2, 3. There was a total of 6 spaces in between those 2 points. So I could have just found the middle of them and drawn the axis of symmetry. For the vertex, it's very easy to find the x-coordinate because it's the axis of symmetry's equation, negative 2. To find the y, you just simply plug that negative 2 back into this x position here and here. So it's y equals 1/3 times negative 2 minus 1 times negative 2 plus 5. So y equals 1/3 times negative 2 plus a negative 1. Negative 2 and 5 is positive 3. Coming over here, y equals 1/3 times negative 3 times 3. Negative 2 and negative 1 was negative 3. Negative 3 and 3 is negative 9. A third of that, that's like dividing by 3, is negative 3. So it's negative 2, negative 3, which you can see here. Now that gave us 3 points. We needed 1 additional. I went ahead and chose 0 just because you had 1 out here and you over here at negative 2. 0 seemed easy. This is where it gets a little more challenging. So you have y equals 1/3 times 0 minus 1 times 0 plus 5. Y equals 1/3 times 0 minus 1 is negative 1. 0 plus 5 is 5. Negative 1 times 5 is negative 5 times a third. You can't divide 5 evenly by 3, so it's going to be negative 5/3. So we've got 0, negative 5/3. 5/3, 3 goes into 5 once, and then it has 2 left over, so it's negative 1 2/3 is about where I plotted that. It is 2 away from the axis of symmetry, so I reflect it to the other side, so it's going to be negative 4, negative 5/3 for your 5th pair. And hopefully this will help you with any of the intercept form that you need to do.